Okay, so session number 8. Session number 8. Agenda for the today's session is Newton's backward interpolation. If you recall, in the last session that we completed is Newton's Gregory forward interpolation formula. So in today's session, you will learn about Newton's backward interpolation formula. The first thing that you will able to first I will show you the formula for Newton's backward interpolation. That formula we'll use to find or to predict the value of a function for interpolation purpose. Okay, so already you are familiar now what is interpolation, is it? And another point is there that we are going to find interpolating polynomial with the help of that backward interpolation. So today's topic is really simple because already you learned about the interpolation. So come to the formula first. Here we have the Newton's Gregory backward interpolation formula. So the formula start as f of a minus xh. This is f of, yes, is there any doubt? So the formula is f of a minus xh is equal to f of a minus x del fa plus x into x minus 1 upon 2 factorial del square fa minus x into x minus 1 into x minus 2 upon 3 factorial del cube fa and so on. So these are not now like combinatorics there. So you should keep in mind these terms are a little different. So that is a backward interpolation formula. And obviously, remember the backward interpolation we use to find the function value near the end of the set of a tabular data. Okay, so whenever we have to predict the value of the function at near the end of the data, we use a backward interpolation formula. Okay, the first important part, you should remember this formula. Up to del cube is enough. Okay, generally all the questions you can do it with the help of this up to the term of a del cube there. Okay, so most important thing is a formula that you have to remember. Come to the question now. So the question is the values of tan x were given. Okay, and we have to find out tan of 0.26. Again, the best part is it is a known function. We know the function is a tan. So tan 0.26 we can calculate on a calculator and we get that answer. We have the answer of tan 0.26. We just have to cross check whether we get approximately same answer with the help of numerical interpolation. Okay, so by the interpolation there. So we are given few values of x and corresponding tan x values were given here. So these are the tan x values here. Now, step number 1 is obviously again a difference table. Remember, the forward difference table or backward difference table, they are exactly same. Okay, only the notations are changing there. So step number 1, we are preparing this difference table. So values of x written here, the values of f of x is written here. This minus this, like 0.1511 minus 0.1003, that is written here. Only instead of delta, we given the heading for the columns as a del there because we are interested in the backward differences there. Now, what is a minus xh here? Yes, anyone? What should be a minus xh?
So 0.26.
Yes, 0.26, because that is a value where we have to compute the function value. In forward interpolation, we use just above value as a. Here, yes, what should be the change? We have to take just below that. Okay. In forward, we taken just above as a. In backward, we take just below that value, just below 0.26. What is that value here in the table? It is a 0.3. So this 0.3 we select as a. This is a minus xh. What is h here? What is the value of h?
0.05.
Yes, that's correct, 0.05. And now we have a minus xh value, that is 0.26, a value is 0.30, h is there 0.05. We can find out x again, exactly same way. Okay, just like when forward interpolation. So you get x is equal to, this is actually a minus xh upon h, and that is a 0.8. Is that clear? Any doubt up to here?
Yes, sir.
Okay, that's good. So this is the now leading differences. These differences are very important differences that we are going to use in the calculation purpose. You will observe again higher order differences are becoming negligible. They are point triple not 2, point triple not 4, point not 4, 1 4. So actually del square also you can ignore. This is also very small. So if you do a calculation with up to delta y also, you are going to get a very good approximate answer for tan 0.26. But yes, as we know the terms up to delta cube, yeah, you can do the calculation maximum up to this delta cube there. So first step, you should write a formula for backward interpolation, and you replace that value. This is f of a minus xh is equal to f of a. F of a is here minus x minus del f of a. This is a del f of a plus x into x minus 1. Now here it is a change, x minus 1. So 0.8 minus 1 upon 2. So that about x minus 1, and this is a del square f of a, and so on. And you will observe tan 0.26 coming as 0.2659. You can cross check it on a calculator also. If you have the doubt, yes, you can ask. Yes, any doubt here? Few things are not written
No,
here.
sir.
Okay, few things are not written here that you can start with like this. Also, a minus xh is a 0.26, where a is a zero point 0.3 and h is a 0.05, and then you can say this as x, and then remaining calculation, that's one. Okay, so come to the next question then, example 2, if you have no doubt here. So question number 2. Now the question is in some words like we are given a deflection and we are given the distances of some experiment, say cantilever experiment. So we have the two things here. One is the deflection and the distances, and we have to find out that deflection d when the distance is 0.95. Okay, so 0.95, if you look in the table, 0.95 lies near the end of the data. So this is the first important observation. This is near the end of the data. Suppose the question is for find for x equal to 0.5, sorry, point 0.1, point 0.1 or say point 0.3. If we have for point 0.1 or point 0.3 which lies near the beginning of the data, then we use a forward. So here we use a forward interpolation. But when we have to find out some values between these values, we use a backward interpolation. Okay, backward. Now here is a case, say 0.5. Suppose there is a 0.5 and we have to find out the value of the function at x equal to 0.5. You can use forward or backward. Any interpolation you can use it, because roughly you are going to get same answer by any of that, because equal number of differences will be available. Equal number of differences will be available for that value 0.5. Clear? Is it clear?
Yes, sir.
How to select forward and backward, that is also important. It is very simple actually. Whenever you have to interpolate the value of a function at the beginning of the data, we use a forward. Whenever we have to interpolate at the end of the data, we use a backward. That's one. So simple. So step one, the difference table. So here is a backward interpolation table. So sorry, backward difference table. My mistake. It is a backward difference table. X values, D values, higher order differences. So this table right now exists up to delta 5 there, up to fifth order backward difference there, in which fourth is already 0 there. This is negligible. So again, we generally do the calculation up to del cube. Okay, this is del cube only. So what should be a minus xh?
0.95.
0.95. What is a?
1.
A is 1. Good. Just making a mistake. First, you told me that a minus xh should be 0.95. A should be 1. What is h here?
0.2.
0.2. Good. And then we have to find out the x here. Has anyone completed the calculation for x? 0.75. Okay, good, Chirag. I think, let me see. No, x is a 0.25. It's not 0.75, Chirag. What is it? 0.75 answer given by Chirag, not correct. 0.25 is x there. Is it correct? 0.25? Okay. And how we got this answer? The answer we get it as f of a minus xh, that is f of 0.95 equal to f of a plus x. Where is x? X is here. X into del f of a plus x into x minus 1 upon 2 factorial del square f a, and so on there. I hope there is no doubt there in the formula and the calculation. Any doubt, anyone here?
No, sir.
Doubt. Good. So second last question then for. So here is the third question. The third question, you will observe we are given the diameter versus area. So few diameters of the circle were given. We know again in this case, remember again in this case the answer is with us because we know the formula of area, because it is already written y is the area of a circle. So pi r square should be the answer, and few areas already given, and the question is find the area for 98. So pi into 98 square, that will be the required answer. And what should be the value of pi we should take? Whether it is a 180 degree, 180 or 3.14?
Vanity.
180. 180 is not the correct answer. Remember,
3.14, sir.
3.14. Everywhere, whenever you do the algebraic equation, in algebraic equation, everywhere you always in the radian mode there. Remember, don't take, but it actually, there is no need to take, but if you want to check actual answer, so you can take 3.40, there is pi is the 3.14 into 98 square, that should be this answer. Okay, so you already know the answer again here. Only here the question is you have to find it with the help of interpolation method. So here the values of x which we are given, values of y, backward interpolation table prepared. Now in this case you should write this formula up to del 4. Okay, don't ignore the del 4 term there. Is it a small? Is it a small? No.
No,
Is it?
sir.
Okay. So whenever point not is there, yeah, you can ignore. But remember, whenever the number is like 4 and that, you should consider, so you should do the calculation with a del 4 there. Here, a minus xh is a 98. This a minus xh is a 98. A is a 100, because just below. H is 5. And then you have to find out x there. I hope there should not be any doubt in doing a calculation your own. Any doubt here?
No, sir.
So this is the last question for today. But remember, the question is a little different. This type of a question sometimes come in the exam. Actually, this question is repeated 2-3 times in your old question paper. Okay, there is a little bit small difference where many students are not able to think. You should go through the question, uh, and you will observe the given is now. The question is estimate the number of men getting the wages between 35,000 and 40,000 rupees salary. Okay, sorry, wages there. So their wages should be in between. We want how many men are there whose wages are between this range 35 to 40k. Okay, but this data is given not in the normal way. So generally we have the data like for x equal to 10, y is 9. For x equal to 20, y is 30, that way. But here we are given the wages for certain range 0 to 10. There are 9 persons whose wages is this much. There are 30 persons whose wages is between 10 to 20k. Okay, that way. So already hint is there in the answer. Yes, what should be the done at the beginning to get the data in a correct way? Yes, anyone?
30 to 40.
30 to, no, I want this data is not in the required form because we cannot solve this data for given the values as it is. So let me take x as a wages, and y as the number of Frequency means number of men's whose wages is x there. Okay, but we are not taking y as that. So let me take y is equal to number of men. Okay, number of men. Okay, getting wages below x. This is the hint. This is a below x. So this is a very important line that you should remember. If you get this step, yes, remaining part is just normal question then. Okay. No, we cannot add and subtract 5k from each interval. If you say if you add, then you'll see what is the main thing. We have to convert this group data. Group data means we are given the data for interval. We have to convert from group to the ungrouped data. So ungrouped data now. So I will take number of men whose salary below 10, below 20, below 30, and below 40. So can you tell me how many men are there whose salary is below 10k? Yes, quick.
9.
9. Below 20?
30.
39.
39 is the correct answer. Below 30? Is it 74?
Yes, sir.
Yes, sir.
And lastly, 74 plus 42, how much?
116.
116.
1?
116.
106, is it?
116.
116.
116.
Okay, sorry. Now, which difference table we should prepare, forward or backward?
Backward.
We should prepare backward,
Backward.
because at the end first we want how many men's whose salary is below 35 will calculate. First we'll find out below 35. Right now below 40, yes, we know 116 is there. Below 35 we'll calculate it, and once we get below 35, already we know below 40, and we want between 35 and 40, then we'll do a subtraction. Okay, so we are going to make a backward difference table. So let I make a first backward table. So this is nothing but 39 minus 9 is 30, then it is 35, then this 116 minus 74 is 42. So these values will come straightforward, these values will come there. This is the first backward difference. Second backward difference, second order backward difference. Yes, tell me. 35 minus 30
5.
5.
here.
7.
7.
Third backward difference,
2.
2. That's one. Now maximum third difference exists only. So tell me what should be a minus xh?
35,000.
35, correct. Not 1000, only 35, because we consider as 35 only. A
40.
A should be 40. H, what is H?
2.
10.
10.
10.
So what should be X? This is 35. Sorry, 40 minus 35 divided by 10.
0.5.
0.5. Okay, everyone check it whether it is a 0.5. Okay, so we have that X as a 0.5. Now start a formula. The formula is f of A minus xh. So I'll write it here. F of A minus xh. A minus xh is 35 here. That's one. F of 35. We have the formula as f of A. What is f of A?
42.
No, not correct.
116.
116 is f of A. See, these are the leading differences. I will highlight here. These are the leading differences that we have. So this is f of A. Is it plus x is there? Yes, anyone?
Plus 0.5 into 42.
Very good. 0.5. This is x into del f of A. So that is 42. Plus, is it plus again? X
0.5 into minus 0.5 upon 2 into 7.
del square. That is 7.
So it would be 116 minus 0.5 into 42.
Here is minus, na?
Yes,
Yes.
sir.
Alternate plus minus is there. That is the key. This is the silly mistake that few student again do. So you should remember the formula properly. Good observation. Alternate plus minus sign is there in the formula. Alternate plus minus is there. So this is the plus, this is minus, then plus, and lastly minus again. So last term is a minus here, which is a 0.5 minus 0.5. Is it minus 1.5 upon 3 factorial means 6, and delta cube it is a 2. Now do this calculation and check whether you are going to get the answer is a 94, approximately 94. Suppose you get 93.6, you can say approximately 94. Are you getting? You have to round up to the nearest digit. Why? Because there are number of peoples. What is the above 35 we are calculating? Number of men whose salary is below 35k. So that we are calculating. Got it? Are you done the calculation?
Yes, sir.
Is it 94? What is the exact number? Yes. What is the exact number? Anyone done this calculation? I want exact number. What number you got there?
Yes, sir. 94.
Exact 94? Or
Yes, sir.
okay, okay. 94.25. 94.25. Okay, if you get 94.25, you will observe the decimals 94.5 and above. If it is there, so we take it as a 95. But it is 95.5 below. If it is below 0.5, we'll take it as 94. So 94.25 will be approximated to the 94. And this 94 that were received, that total number of men whose wages are below 35k are 94. But already we know below 40 there are 116. And the question is, find the number of people whose wages between 35 and 40. Okay, so obviously we take 116 minus 94, we get 22 people's or 22 men's are the wages between 35 to 40k. Is that clear? So lastly you should add this line, any doubt, anyone? No doubt.
No, sir.
So everything is clear. Remember, this is one big variation, and this variation, whenever the data is in the group form, so either you generally convert it as a below 10, below 20, below 30, and below 40, and then you will continue with your calculation, and at the end you can get the required there. So this way you have to always convert the data, group data to the ungrouped data, and use for interpolation purpose. So that's for today. So today mainly we learned about this backward interpolation. I think there is one more question because we not seen a question where we obtained that interpolating polynomial. Let I check. No, so it's not here, but you can try this example as exercise because there is one more question. See, we want interpolating polynomial for this data. Okay, so whenever the question is find interpolating polynomial for the data, no need to use a backward interpolation. Yes, better to go with a forward interpolation only, because you can select a as a 0, then h as a 1, and you get fx there directly. So this is the forward. So I think the answer is not correct. Is the answer is correct? Okay, first data satisfied. If you put x as a 0, it is 3. When you put x equal to 1, so 3 plus 2 plus 1, 6. That is also correct. Then 2 is 6 plus 4 plus 3. I think this answer is not correct. Clear? Is it? Because this you replace x by 2. Replace x by 2. Are you getting 11? No. Is that?
Yes, we are getting 11.
11. Okay. Where is my mistake then? So why it is a quadratic we received? Okay, you can check then. generally you should get a cubic polynomial there. You should get a cubic polynomial because 5 pairs you are given 1, 2, 3, 4, 5. Not cubic again. Fourth degree polynomial should be the answer. Okay, you can check. Okay, you can check for 3 and 4 also.
So it's right.
It's right. Okay, so maybe some terms becoming zero then. Okay, you do actual calculation. So higher degree terms probably goes to the zeros there. You can check with your own calculation. And this is the question similar to that, whatever we seen right now. Only we want the wages between or below 15,000. We want below 15,000. So exactly similar way we have to proceed. But what should be a small change? How to get
Forward difference will
forward
be there.
interpolation. Correct. Very good. Very good. So you should use a forward interpolation here. Good.